As we have studied fluid dynamics, in fluid dynamics we have seen what is Reynolds transport theorem, Navier-Stokes equation, conservation of mass, conservation of energy and conservation of momentum. So, taking all those concepts into account, let us solve few problems on bend. So, what is given to us? A diameter, a 300 diameter pipe carries water under a head of 20 meters and velocity of 3.5 meters per second. So these all things are given to you. That is theta, that is a diameter is given to you, pressure head is given to you, as well as velocity. If the axis of the pipe is turned through a 45 degrees angle, so a theta is given to you as 45 degree. We have to calculate the magnitude and the resultant force on the bend. So let us write down the things which we know. That is diameter is equals to 300 mm. So this is 300 to the power of 10 raised to minus 3 meters. So that is a 0.3 meters. Then the pressure head is given to you as equals to 20 meters. So pressure head we can write down pH as 20 meters, or we can write down that as also equals to HP, that is head due to pressure. Velocity is equals to 3.5 meters per second, which is given to you, and it is inclined by an angle of 45 degree. So we have to find out the resultant force and the direction, resultant force at the bend and the theta which we have to calculate. So now let us draw the diagram which is bent, which is bent at an angle of 45 degrees. So if this is the inlet of the pipe, it is bent at an angle of 45 degrees, but note that this is not a converging or a diverging bend, this is a constant diameter bend. So here the diameter is going to remain constant. So now we'll consider this as inlet as a section 1,1, this as outlet as a section 2,2. So now next, what is given to us over here is diameter d1 and diameter d2, both are equals. D1 is equals to d2 is equals to 0.3. The pressure which is acting over here is P1. The pressure which is acting on section 2 is P2. And the force due to the pressure is P1 into A1, and the force due to pressure is P2 into A2. Now along the horizontal it is inclined at an angle of 60 degrees. Now the fluid is flowing from section 1,1 to section 2,2. So the velocity at the inlet is V1 and the velocity at the outlet is V2. So these all things we know in this entire part. So now let us calculate the area of cross section, then we'll calculate the velocities, pressure and all the other forces. So now let us calculate the area of cross section. That is A1, that will be equals to A2, that is pi by 4 into d square. So this is pi by 4 into 0.3 square, which comes out to be 0.00707 meter square. That is A1 is equals to A2. So these are the things which we know. Then we know that Q is equals to, that is A1 V1 is equals to A2 V2, but since area of cross section is same, then velocity will be also same, that is a Q upon area, that is the net area. A1 or A2 both are same. So this will be equals to 3.5 meters per second. Actually the velocity is given to you. Now we'll calculate what is Q over here, that is value of flow rate. So now Q will be equals to A1 V1. So this is pi by 4 into d square. into V1, that is a 3.5. So this will come out to be 0.2475 meter cube per second. So we have evaluated what is value of discharge, that is in a meter cube per second. Now, next part, what they have given to you, the pressure head HP, that is given as 20 meters. So the pressure head is given to you as a 20 meters. So now we'll get this as P1 is equals to P2, that will be equals to rho G into H. Now, why the pressure heads are same? Because it is going through a pipe or having a uniform pressure. So that means the bend is having a very small amount of force which is acting on that part. We have got P1 is equals to P2, that is rho G into HP. So this is 9.81 into density of water is 1000 into HP, that is 20. So P1 is equals to P2, that will be equals to 196.2 into 10 to power 3 Newton per meter square on evaluating this entire part. So now we have got value of P1, we have got value of P2, we have got V1 as well as V2, which is actually same. Let us draw our master diagram. So now for drawing our master diagram, what we need to write over here, first we need to write force, then we have to write velocity, then we have to write the left hand side part inlet, the right hand side part as outlet. Let us draw these dividing lines between the inlet and the outlet. So now let us write down the force at the inlet. So from our diagram, the forces at the inlet is equals to P1A1 and the outlet is P2A2, but it is inclined at an angle of 60 degrees. So now let us write down this part. This is a P1A1, that is force at the inlet, and it is downwards, that is a P2A2. This is A1, this is P2A2. Now it is inclined at an angle of 60 degree with the horizontal. So this force over here will be P2A2 cos of 60 or cos of 45 degrees. This is actually 45 degree. So this is a 45. Similarly, this is a P2A2 sine of 45 degree. In the previous diagram also, we had not considered the angle of inclination. This is actually 45 degree, not 60 degrees. So now let us continue with the diagram. So the velocity component at the inlet is horizontal. So this is a V1, that is a 3.5 meters per second, and at the outlet, which is going away, which is in the first quadrant, so at an angle of 45 degrees. So it is in the first quadrant at an angle of 45 degrees. So V2 is equals to 3.5 meters per second. So it will be converted into two components. This is a 45 degree. So what we'll get over here, this is a 3.5 cos of 45 degree. This is a 3.5 sine of 45 degrees. So we have made our master diagram. Now it is just a part of evaluation. So now let us apply what is summation of fx. Summation of fx will be equals to the mass flow rate into final velocity along x direction minus initial velocity along x direction. So now let us write down the fx, that is the force on the bend, plus initial and inlet force as well as outlet force. So inlet force is P1A1 towards right. So for x direction, we'll consider this as positive, this left hand side as negative. For y direction, upward as positive and downwards as negative. So now, since it is going towards right, this will be P1A1 to positive, minus it is going towards left, hence P2A2 will be negative. So let us write down this. So this is a P1A1 minus of P2A2 cos of 45 degrees, which is given to us. Next, that is equals to mass flow rate, that can be written as a rho into q, final velocity at vx minus initial velocity at x. So final velocity which is at outlet along y direction is a 3.45 sine of 45, but initial velocity along y direction is a 0, so we won't consider that part. So this will be just equals to v2 cos of 40, rather v2 v2 cos of 45 degrees. Yes, the velocities will consider along x direction. Along x direction, the final velocity is there, that is 3.5 cos 45, but initial velocity is also there, that is 3.5. So this will be final velocity minus of uh, initial velocity, that is v1. So now we have considered all the velocities along x direction. Let us solve this problem. So this will be fx plus p1a1, p1a1 and p2a2 both are same, so over here we can take this common. This is 1 minus cos of 45 degrees, so this is rho into q. V1 and v2 are same, so we can take this also as common, so that is 3.5 into cos of 45 minus 1. So on evaluating this entire part, on substituting the value of P and area A1, we can calculate this as equals to Fx equals to minus 4.316 kilonewton. So Fx will be equals to 4.316 kilonewton, which is going towards left. So we have calculated what is the value of Fx over here. So now let us apply the same formula for y direction. So for y direction, let us apply the formula, that is summation of Fy is equals to mass into final velocity along y direction and initial velocity along y direction. So Fy plus, let us see for y directions. So y direction, there is no force in y direction at inlet, but outlet it is a negative force, that is P2A2 cos a sine of P2A2 sine of 45 degrees is equals to, this is rho into q, final velocity at y minus initial velocity at y. Final velocity along y direction, along in y direction is 3.5 cos sine of 45. Initial velocity is absent, as we have seen earlier also, so this is v2 sine of 45 minus 0. So this is Fy minus the pressure over here is 196.2 into 10 to power 3. The area of cross section, which we have initially calculated as 0.0707 into sine of 45, which will be equals to 1000 into rho, which 1000 into q, that is 0.2475, which we have initially calculated, and value of v2, which was equals to v1, that is 3.5 into cos of into, not cos, rather sine of 45. So on evaluation of this entire part, we get value of Fy as a 10.42 kilonewton. So the resultant can be calculated as a square root of Fx square plus Fy square, that is a resultant force. So on evaluation of that, this will give us 11.9 11.28 kilonewton, and theta will be equals to tan inverse of Fy upon Fx. So theta will be equals to 67.5 degrees, but it will be in the clockwise direction because the resultant of this entire part will come in the second quadrant. I hope you have understood how to calculate the forces on bend for a problem having uniform diameter and uniform velocity, where pressure force, or rather pressure head, is given to you. That is the head difference between the both of the inlet and the outlet is given to you. Thank you.